So today we're going to be going over loops as well as switch statements. So first we have a loop here. So loops are good for if you want to execute a code block like this one multiple times and you don't want to have to write it out multiple times. You can use this instead. So for a for loop, we can use that when we know exactly how many times we want to iterate through the loop. So here's the syntax for it. And here we have the initialization of our counter variable. I is less than max squares, which is set to be 10. This is going to be the condition that we're checking for before we continue doing the loop again. And we have I plus plus, which is what we're going to be doing after every loop, usually incrementing our variable. So here we have I is equal to 0. Squares equal to 0 times 0, squares equal to 0. Then we're going to increment I by 1. I is now equal to 1. 1 is still less than 10, so we're going to do squares equal to 1 times 1, and then we're going to print out our square, which is going to be 1. We're going to increment again, so now I is equal to 2. 2 is less than 10. Squares equal to 2 times 2, which is 4, and we're going to print that out. So basically this program prints out numbers that are square numbers, starting with its factors of 0 to 9. So we can print that, we can run that code. Perfect, so got what we expected, 0, 1, 4, 9, all the way up to 81. A more complicated version of a for loop would be a nested for loop. So this is good for if you have multiple variables you're iterating through. Such as for this one, we want to print all the prime numbers from 0 to 10. So I just started with 1 and we're initializing with 2 just to make things a little bit easier with the math since every number is divisible by 1. So here this bigger for loop is going to be going through the numbers 1 through 10. And then the smaller for loop is going to be going through all the numbers less than our possible prime number and dividing that number by the possible prime number by that number to see if it's a factor, using the modulus to see if the modulus is equal to 0. So let's say we're up to 5 in our loop. Has factors is equal to false. Then this piece of code is going to be going through 1 through 4, dividing 5 by those numbers. And if it gets 0, it's going to set has factors equal to true. And then at the end of going through all the numbers less than 5, it's going to go into this if statement, and this if statement is going to print out 5 if has factors has remained false, which it has. So we can print that out, and then we can run this code. Yeah, perfect. So the prime numbers between 0 and 10 are 1, 2, 3, 5, 7. So I said that for loops are good for if you want to execute a code multiple times, and you know exactly how many times you want to iterate through. And a while loop is good for if you're not exactly sure how many times you're going to have to iterate, such as you're waiting for a user to put in a good input, or let's say for a game, you want the user to keep picking chess until they finally find a chess with a prize. So that's exactly what this program does. While prize found is equal to false, we are asking the user to pick a number, and then we are taking in that user input. So a switch statement is when you're checking for an expression and you have a lot of them to go through. Instead of using a bunch of if statements, you can use a switch statement. Usually you're using it for integers or characters. So for this one, we have our picked number, and if it's 1, we'll execute this block. Then we have a break, so we break out of the switch. It doesn't check the rest of this. We break out of the switch statement and we move on. If they put a 2, then we'll execute this block, which actually has a prize. So we're also setting prize found equal to true. And then we're breaking it out again. And then we have that for 1 through 5. We also have a default. So if none of these cases are the case, so the user picked a number that is not 1 through 5, then we have the default statement. which is just everything else, and we see out you did not pick a chess since it was an invalid input. So basically what this program does is it keeps asking you to pick a chest until you find one with a prize. And then it will tell you, I'm glad you found something once you finally found one. So we can run that. So let's put in some invalid inputs like 7. It says you did not pick a chess, and it's asking us to pick again. Let's pick one that does not have a prize. So 1 does not have a prize, please pick again. 3 does not have a prize, it's asking us to pick again. And then 5 has a prize, so it tells us what our prize was, and it moves out of the loop and tells us, I'm glad you found something. So this program integrates what we've learned, both our loops as well as our switch statements, into a program that is able to tell us the day of the week as well as print a little calendar of the month for a given date from the user. So for finding out the day of the week, we are going to be using Zeller's congruence, which is basically a little algorithm where you add like the year, the date, different number codes that you get for different months and centuries, and then you get a number, a total, and you divide it by 7, and the remainder tells you what day of the week it is. So for the century codes and the month codes, we can see here, and here, and here, as well as for the modulus, where we're finding the day of the week for here, we're going to be using switch statements to make things a little bit cleaner. And then our defaults for these switch statements, so if we get a century or let's say a month that is no good, we're going to get, and that isn't listed, the default is going to be invalid month, and it's going to set error to true. And the reason we're setting error to true is because this is all in a while loop that while error is true, it's going to keep asking you to pick a date. So we're going to keep getting dates from the user until we get a valid one that we can actually find the day of the week for, as well as print a calendar for. So besides that, when it comes to printing the calendar, when we found out the month, we also added a day max. And then we printed out spaces, and we're going to keep printing out those numbers so long as the day max has not been reached yet. So we can run this to kind of see how it works. Let me type in some bad user inputs so we can see how the program responds. On the 2100, 1207. Please pick a date after the year 1700 or before the year 2100. The date could not be determined because of an error, and it asks us to pick again. Let's do 2000, 1307. Invalid month, since we chose the 13th month of the year, could not be determined because of the error. And then let's do 2012, 32. The day of the week could not be determined because of invalid day. And then let's choose a good input, 2012, 07, so December 7th, 2000. And it says the date you picked was a Thursday, and then it prints out a little calendar, and it was a Thursday. That is true. And this is what the calendar looked like for those dates. So that is basically how the program works. That is how loops work. That is how switch statement works. Thank you for watching.